Shunt! Wow, how do you know?
Parallel with the load.
Yeah, well, we learned that. Q1's in parallel with the load now. I still have a Zener diode. I basically still have the same elements as I do in the series, except I decided to go ahead and place the transistor parallel with the load. Amazing. And now, guess which component's not providing the base bias?
CR1.
What is now?
R3.
Now R3. Interesting. There's some truths about that I brought up. If I did this, is that true? VR3 equals base emitter voltage equals forward voltage?
Yes, sir.
It's all true. When you did the lab, is it true?
Yes, sir.
It is. Also, the collector voltage equals what other variable, if you will, Mr. Newland?
The collector emitter voltage.
Yeah, don't forget about that. Hey, you might be asked, hey, collector voltage equals what? Oh, it's the same thing as VCE. Adrian, go. Does this thing make sense?
Yes, sir.
And if it doesn't, if you don't feel like, I don't get it, you can ask me, I'm going to tell you anyway. Collector voltage, I take the voltage reading. Red lead on the collector, even over here, black lead to ground. Oh, look, there's no emitter resistor. That must be the same thing as VCE. It is. VR3, base emitter voltage, forward voltage, it's all the same stuff. VR3, oh, that's how we do it. Base emitter voltage, oh, that's how we do it. Oh, this, it's the same thing. There's no emitter resistor. Forward voltage drop, well, gee, it's that 0.5 to 0.7. We always use 0.6 when we're calculating things in this course. R1 and R2, what are they?
Series dropping. Series.
Yes, they perform the same function every night, just like R2 and R3 in the series regulator. They do what? Try to take over the world. I've told that joke like 4 times now. Come on. Series dropping. Now, if you're getting sick of hearing it, I don't care.
It's not funny.
It is.
I don't care about it.
There you go. R sub S, same deal. Those two resistors perform the same function as R2 and R3, the same thing. Current handling capabilities. It just so happens this time they're like, what the hell are they? Like 100 ohm resistors. So combined they're 50 ohms. It's basically the same damn thing. CR1, do I got to go into what that does now? No! This time I'm calling it a 3-volt Zener. Why? Because I can. R3, what's its job?
It's supposed to set the forward voltage of the base. Which value of its voltage?
Yeah, that's the deal with this. Even though this is true, its purpose is to establish the current to the Zener. It's going to drop, well, what's going to drop? It's in parallel, so it's the same thing. So R3, we'll just write right next to it, hey, path for Zener current. It's its job. And since I don't have an emitter resistor, my base voltage is what? What's the base voltage?
Same as VR3.
Yeah! Couldn't I write that too? Couldn't I write that as well? Could I write that as well right here? Look.
Yes, sir.
Could I do this? No, Adrian.
Yes, sir, you can.
That's all the same stuff. Why do I show you this, that, and the other? It's like the same thing, or similarities, or differences between equations or variables. Why do I do that? Well, not only you might see variations of, because I'm trying to get you to use your thing between your ears. What is that? All right, wise asses. There's a lot of things between ears, aren't they?
Yes.
I'm talking about your brain.
Nice.
Gotta think. Just like Aretha said, you gotta think. You don't know who that is? I'll tell you later. Q1. What do we call this?
Regulating element.
It's still called the regulating element. It still is, but it's not a series pass this time, is it?
No, sir.
No, because it's in parallel with the load. R4 special. What does R4 do?
Assistant Q1 in conduction.
Yes. One more time. Is R4 in this circuit the same as the R4 in that circuit?
No.
No, its jobs are different. Let's screw it up too. R4, its job is to basically drop the inverse voltage of VCE. Doesn't VR4 and VCE in this circuit, aren't they like this?
Yes.
Yes, because this circuit, for some, is a bit easier to realize than this one. Because, for some reason, hey, parallel circuits seem to be easier for folks to follow. How they work. R5 this time is what? This time it's R5's the bleeder. You need to know what these components are responsible for. You need to know. How soon?
Tomorrow.
Better know that trash tomorrow. You better be ready. C1, same job, right? Same job as all the other capacitors and all the other regulator circuits. Surge stability. And then you got your load. What does B out equal this time in this circuit? What is the formula?
ECR1 plus 4 volts.
Uh-oh, now we're adding the forward voltage. Holy crap. Still a polarity thing. Look, the cathode's attached to the positive or more positive portion of the circuit, right?
Yes, sir.
Hello! Negative. Oh, and it's a, what kind of transistor? NPN. P-type material. Oh, that looks like series 80 to me. Add. Could we also go and say Zener voltage plus base emitter voltage
Yes, sir.
plus VR3
Yes, sir.
plus base voltage in this circuit?
Yes, sir.
It's all the same thing. All right. Load line characteristics still the same? VCE and conduction, they're inverse.
Yes, sir.
If you figure out the VCE of the transistors increasing, automatically, come on, conduction decreases. Don't make this harder than it has to be. Some students do. Read into things, make it hard. I'm giving you the most simple format that I can for this stuff. Trying to make it easy as possible. Redraw. Well, gee, it's just a parallel circuit, isn't it?
Yes, sir.
Series drop-in resistors, though. Technically, I probably would call this a series parallel circuit, right? Because I have a series portion, and then the rest of it's parallel. But we don't really care so much about this because we know they're small ohmic values. Voltage drop is very small because they're small. The purpose is that current handling capability to handle current that's not needed by the circuit and dissipate it. It's the purpose, current handling.